Well, hi, Professor. Since demoing my code is very time consuming, so I put all this kind of demoing part in the last part of the video. So if you are interested in the demo, please refer to the last part of this kind of video. Well, so hello, Professor, and I am Yucheng Wang, and I'm introducing our course project, which is done by Yucheng Wang and Hongsheng Xie. So firstly, I will go through our code we have, and it should be in which was source code folder. Yeah. So you can see here's task 1 and here's task 2. It's all the code, and you can find all the code in this all code file, and you can find all the results of the task. So firstly, we'll begin with this create table SQL file. So we are actually creating a schema named FIFA, and we will create a table named FIFA player info under this schema FIFA. So, and all this kind of columns, and this columns is after we clean the data and after we drop some of the columns. So the data cleaning part is in task 1. So basically for our task 1, we use the try and except structure here to catch every possible error. And here it's just we are trying to read all these CSV file into our local machine, into the PySpark. And here's the read. And we actually add a new column which name is year, and which is an indicator of like this kind of data is from this kind of CSV, and we will need that in the future. And then we have a threshold, which is the half of the total rows. And if some of the columns have the rows, which is not an A, and this number is lower than the threshold, we'll just drop them. And finally, we find that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So like 12 of them are dropped based on this kind of criterion. So after drop this kind of column, we are like manipulating on the other columns with the notation plus and the notation minus. So here what we do is we just split this column into 3. So the first one is the first part of the of this column, which is a number, and the second one is another number, and the third one should be plus or minus. So we calculate a new result in a new column, and we just drop the useless column after we have the result. And then we indicate a imputer to impute the NA value in some of the numeric columns. We are using the mean to impute this kind of column. So after that, we just need to connect our PySpark to our Postgres. And here's my username and the password, and we just save this table into database, and we will return this table. So here's task 1. And then for task 2, the first one. So the first one should be list X player who achieved average highest improvement across the skill set. So in this kind of a task, we have 2 input. We have 3 input. The first one is year 1, the second one is year 2, and the third one is X. So basically, X will be the row number of the return, and year 1, year 2 should be 2 years, and year 2 should be a more recent year comparing to year 1. And if year 1 and year 2 is not in this set, we return invalid. And if it is greater than year 2, we also return invalid. And X should be integer. and it should be greater than 0. So you can see here, we also use the try exception structure to handling the error. And this part is just, we are trying to read the data from the database. So never mind. And so here it should be the data of first year, and it should be data of second year. And we are actually taking average on this kind of a skill set. And actually we have more skills, but we only pick this kind of 6 skills because picking too many skills is just a very like boring thing. So we just choose some of the skills as an example. So by taking the average of on this 2015 and on this 2020, we can like use this one to minus this one. So we can have the improvement within this time period. And after that, we can have the result. And the result is the player with the most improvement during the year period of 2015 to 2020. And for task 2.2, it should be Y club that has largest number of player contrast ending in 2021. So it's quite straightforward. So for Y should be an integer and it's greater than 0. And here we just read all those data into PySpark. And for here, we just filter, and the filter is similar to select. To select the column, which is equals to 2021, and we just group by the club, and we count the number of the we count the number of the player with the contract relevant to 2021, and we just sort it in descending order, and then we will have the clubs with the most number of players whose contract valid than 2021. And for 2/3, it is the club is the largest number of players where the greater than 5. And I can use any kind of year, and if other teams have same number of players, we should print something on the screen. Yeah. So we have 2 input, and the first one is the return column Z, the number of return row Z, and the second one is the year, and the default is all. All means that we are using all the data, and Z should be a integer, and Z should not be smaller than 5. And after we read all data inside, so here, if it is default, year equals all, we are using all the data. And if year is in this kind of set, and we are using this data from the specific year, using the column we added before. So else, we will return invalid input. So yeah. So then we just group by club, and we can find the most the club with the greatest number of players. So we group by club and count, and we sort it in this descending order. And here is the variable that is testing whether all the number of players of the clubs are the same. So if it is the same, we will just return all the same. And yeah, else we'll return the most popular club. And basically 241 and 242 is all for the 2/4 task. And I split it into 2. One is the national position and one is the team position. And they're quite similar. So I'm only going to talk about the task 241. And also here is year equals all, and it's a default setting. It's saying that we're using all the data. And if year is in 2015 and 2020, this is kind of set. We're gonna use only 1 year, and else we'll return just invalid input. And here, we just group by the national position and we count it and we sort it in a descending order. So here the problem is, it is possible that the first one in the data frame we have is NA. So if the first one is NA, we'll return the second one, and which is the greatest, which should be the most popular national position. And if the first one is not NA, we will return the first one. So it's basically the same with this. So for task 2.5, task 2.5 just asked us for the nationality, the most popular nationality. Yeah. And the default data set we're using is all the data we have. And if it's not all, we will pick one inside of this. And if it is inside of this set, we're using the specific year as Euro. And here is quite similar to task 2.4. We just group by nationality and count it and sort it in a descending order. And also, if the first one is noun, and we return the second one, and if the first one is not noun, we just return the first one. So yeah, I guess here's like all of the what we have. Oh, here, and here is the test file. Actually, I put all the tasks inside, and yeah, from here should be the test. Yeah, here should be the test. And I will mention that later. And then we can see the test result for the time reason, because every time I run this test.py, it should spend a long time. So I've already run this before. As you can see, after I ran this kind of test, all the tests actually passed. And here's 13 pass and 11 warning. And the warning is because of the Hadoop or Python's version. It's not a big deal. And then I will go through the README file with you. So firstly, the result for each task we find in the allcode.ipynb file in the source code folder. And firstly, I'm going to talk about how to make the code work in a new computer. Firstly, you need to navigate to the source code file and find create_table.sql. You can run it in your pgadmin, or you can run it in Python to create a schema and also create this kind of table. Whenever create a table, you can run task 1 to populate the table by using the CSV file for task 1. But honestly, you need to change the path here, because it's my CSV files path on my local computer. You need to change them all. And after changing the CSV file, you also need to change the database setting in the task 1. And here's the username and the password. You need to change all of them. And for task 2, and they will be quite similar. For each task in task 2, you need to change the username and the password. And after running all those code, I think you're fine. And you should also, in your terminal, you should type pytest and test all the result. Yeah, for task 1, we just created this table and we do the data cleaning and invitation task. And here the constraint is the data type. I actually set all the numeric type into integer, like some of the skills, and they're all integer. And the rest of the variables like name and etc. I set them like varchar, variable char, variable with proper length. Yeah. And in the data cleaning process, we just remove the columns containing lower than 50% of data. And this kind of columns are this. And the primary key here is unique and SOFIFA ID. And primary key is also incremental, and other variables are not. And some of the variable, yeah, we have already mentioned that before. So here's a screenshot of the DB visualizer, and here's the schema FIFA, and here's the table, and here's the general view of the variables. And for task 2, we can find the source code, as I mentioned before. And I will talk about something about my task for each task. And firstly, I mentioned here is we are using try and except this kind of structure to capture the if there's anything wrong in this kind of code. And I'm going to talk about a scenario I tested. So we actually testing this kind of for each task in the same structure. So for task 1, it is just we populate the data and do data cleaning. So we did not test as happy pass and also a sad pass. We just did one test. So here we are looking for the data as null or not. So if it is null, it means that the data is not populated into the database. And also we are testing about the count. And the count should be equals to a specific number, which is this number. And if it's not, it means something is wrong. And also for task 2, we are in the happy pass, we are always testing some of the possible input, like year 1 is 2015, year 2016, and it's actually very possible input. And we test them to see whether the result is correct or not. And for set pass, we are trying some invalid input. For example, here, the year 1 is not an integer, and we'll see whether it can have a correct output or maybe say return. And we actually did this kind of things similar for other tasks. For example, yeah, here we just test 5 and 7 is the output length of the output. And here we tested some set pass. It should be some invalid input. And here's the same. Yeah, here we tried this string instead of integer. And here we try some weird year, 2038. And yeah, I guess here it's all the same. So after running the testing, we actually find that everything passed, and the coverage actually is 100%, like the figure shown below. And I guess then I will show you some result of the each tasks. Just in our code. And I actually plan to run all the code in the video, but I found that it's really time consuming and my computer is quite old, so I can just show the result here I ran previously. So for task 1, if it succeeds, it should return the whole data frame. So you can see the whole data frame is after deleting all the columns we don't need. And we can see all the data here. There's no NA inside, and we have all this kind of integer value, and there's no this kind of structure like A plus B or A minus B. So it seems like everything is fine. And for task 2.1, we just used year 1 as 2015 and year 2 2020. And the output number is 5. Yeah, so here's the output. And for task 2.2, the number should be y. And when y is 5, we have 5 output. And for task 2.3, the parameter is d, and it should be greater than 5. So we tried 5. So we also have 5 returns value. So for task 2.4.1, we're actually using our data, and the result is sub. for two, the result is the same. It's also solved. And for 2.5, we are also using the default pattern, default setting, and the most popular nationality is England. So, we actually did not deploy our code on the we did not deploy the code on cloud. So I think it's like, yeah, I think it's out of our project, and you can find everything you need in the README and also in the source code file and the test to be inside of this test folder. So yeah, I think that's all of our presentation, and thank you. So here we are just trying to run the code because it's really time consuming. We'll run code here because the terminal, I can't really use the terminal. I don't really know why. So for task 1, so we need to wait for a while. So maybe I won't cut this kind of video. You can just try to find the information you need. I'm really sorry about it, because it's really slow. So here's return the data frame. Task 1 returns a data frame. This is the subgroups ID and screen like this. And actually it is populated into this kind of data frame. And for task 2.1, yeah, it's the 5 name we have. So 2.2. Yeah, after running, we have this 5 name. And 2.3, yeah, it's kind of quick. And just the first part of the 2.4 shows is the sub. And the second part, it also shows is the sub. And then the last part shows is the England. So for testing part, we're going to do it here. So the part is very slow. Test. I'll wait for a while. So you can see we have finished running the test file and get the same result as I said before. So that's all.